Okay. Today, we have already actually talked about trigonometry part 2. It was about use of sine rule and cosine rule, the relationship between the sides of the triangle, and after that, the area of a triangle, and some different questions involving those concepts. Today, we will do kind of review questions or a similar revision test. What we have done so far, we're just going to revise and solve mixed problems related to those concepts. Okay. Let's start with this question. In this question, in triangle ABC, the length of side A equals 5, and B equals 6, and C equals 7. Number one, question A, find the area of triangle ABC. B, hence or otherwise, find the length of the circumradius, and hence or otherwise, find the length of the in radius. Say that it is 5, 6, 7, and suppose that here we are given this triangle. Let me draw here. We are talking about some kind of triangle like this. Okay, so this side is, let's say it is 5, and this side is 6, and this side is 7. Opposite A, it is 5, so this side should be A, and C, this one is C, and this vertex is B. Okay, so we are talking about this triangle. First, we have to find the area of this ABC. Since all sides are given, we can use the Heron's formula. To continue this solution, actually for part A, let's find the semi-perimeter of this triangle, which is equal to 1/2 times the sum of the length of its sides. That is 5 plus 6 plus 7. That's equal to 5 plus 6 is 11. 11 plus 7 is 18. And half of 18 is 9 centimeters or units. That is a semi-perimeter. Now, what is the area of triangle ABC? That's equal to square root of S times S minus A times S minus B times S minus C. That is the Heron's formula. And also we have, or actually we already proved this in our previous lessons. So from here, square root of what is S is equal to 9. So 9 times 9 minus 5, that's equal to 4. 9 minus 7, that's equal to 2. 9 minus 6, that's equal to 3. So 9 times 4, it is 36. Square root of 36 is 6. So that's equal to 6 times square root of 6 units squared. That is the area of this triangle and the exact value. And in part B, hence or otherwise, that means that either using this result or using any different method, find the length of the circumradius. Circumradius, actually, know that it's a capital R. If you just draw a circle, actually, what is it? If you draw a circle, something like this, okay, we can draw a circle that passes through the vertices of this triangle. Okay, so this one is, let's say, the center of the circle. We are looking for this capital R. And also we have already proved that actually the area of this triangle ABC, that is equal to A times B times C over 4 times the radius of the circumcircle. So now we have just found the area of this, right? From here, we can just write here, what is A? A times B times C, that is 5 times 6 times 7 over 4 times capital R. On the right hand side, we have the area of the triangle. In question A, we have already found, that's why, hence means that I'm going to use this result. So that's equal to 6 times square root of 6. Now, solving just this equation for r, we will get that r is equal to 5 times 6, or let me just write it as 5 times 6 times 7 over 4 times the area. Area is 6 times square root of 6. So the 6, they cancel each other, and that's equal to 5 times 7 is 35. And also, if you multiply numerator and denominator by square root of 6 in order to rationalize its denominator, then here we get 35 square root of 6 over 4 times 6, that's equal to 24. So that's the exact length of the circumradius. That means that if you just draw any circle, actually where the vertices of this triangle lie on this circle, the radius of the circle would be or will be 35 times square root of 6 over 24. And how about C? And also in C, let me change. And also see, we have already proved that the area of this triangle ABC, and also it can be found using this in radius. That's equal to, what is it? S times R. What is our S? Again, S is the semi-perimeter. We have just found this here. Now, I'm just going to use this. What is the area of this triangle ABC? That's equal to 6 times square root of 6 equals, how about our S? That's equal to 9 times R. So from here, dot, 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 R is equal to 6 times square root of 6 over 9. Or if you just leave this or write this in its lowest terms, 6 and 9, right? The highest common factor is 3. By dividing numerator and denominator by 3, we can just simplify this further. So it's by 3, it is 2 times square root of 6 over 3. That is the radius of the inscribed circle. That means that if you just draw a circle that actually touches, right, the size of the triangle inside the triangle, let's say here's something like this, okay? So let's say this one is, that is R. So that's the value of R. Question 2. In triangle ABC, A equals 8, C equals 14, and B is equal to 60. Find the area of triangle ABC. So solution. So let's say we just draw any triangle, not drawn to scale. Okay. And suppose that this C is 14 and A is, let's say this 8. So this one is, this vertex is A, this vertex is C, and this one is, it is B. And A is 8, C is 14, angle B is 60 degrees. So this angle is, it is 60 degrees. Find the area of ABC. Okay, so now how can you find the area of this ABC? And just using the sine rule, right? So the area of triangle ABC is equal to 1 over 2 times 8 times 14 times sine of 60, right? A equals 8, C is equal to 14, and angle B is equal to 6. That's it. So that's equal to, and the 1 over 2 times 8, that's equal to 4. 4 times 54, that's equal to 56. And what is sine of 60? It's a special angle that's equal to square root of 3 over 2. So 56 times 1 over 2, that's equal to 28. So the area of this triangle is 28 times square root of 3. If everything is in centimeters, then the area is 28 times square root of 3 centimeters squared. Question 3. In question 3, triangle ABC, A is equal to 45 and B is 60 and A is 16. Find AC, find AB, and hence or otherwise find sine of 105. So we'll also draw this here. So we are talking about, we just draw the sides, okay, and 60 degrees, maybe it is something like this. Okay, 45, it is something like this. Okay, so this angle is 45 degrees and this one is 60 degrees. So this angle should be equal to 75 degrees. Okay, it's not drawn to scale. And the angle A, 45, so this side is A. Angle B, 60, this vertex is B, and this vertex C. Okay, and also it's given that the length of A, right, that's equal to 16. So what is the question? Let's say this is B and also C. We don't know B and C. Just right here. Okay, this length is B and this one is C. It says find AC. What is AC? So we have to find B. And find AB. What is AB? That's equal to C. Also, we have to find this. Hence or otherwise, find sine of 105. Okay, so solution. Let's start with A. Okay, so I'll just use again sine rule here to find B. So B and over sine of B. So actually B is faced by angle 60. So here we have sine of 60. That's equal to A, that is 16 over sine of 45. Now from this, what is B? B is equal to 16 times sine of 60 over sine of 45 degrees, which is equal to 16 times, what is sine of 60? That's equal to square root of 3 over 2 times. And how about sine of 45? 1 over square root of 2 or 2 over square root of 2 over 2. Since it's a denominator, right? That's equal to, I can just write here square root of 2. All right, that's square root of 2. Because here we have sine of 45 in the denominator, that's equal to 1 over square root of 2. So the square root of 2 goes up. So that's equal to then 16 times 1 over 2, that's 8. So the answer is 8 times square root of 6. So the length of AB, let me just write here, AB, that's equal to B, that's equal to 8 times square root of 6. And how about B? Question B, it says C, right? We have to find C. How can I find C? Actually using, what is it? Again, sine rule. So here we have a C over sine of 75 degrees is equal to, what is it? 16 over sine of 45. Okay, now from here, let me just draw a line so that I can use more space. Okay, now from here, what is C? C is equal to 16 over sine of 45, that's 1 over square root of 2 times sine of 75. Okay, so I'll just open the window and one more time, we will evaluate this, the exact value. In our previous videos, we have already done, but here, and since also it says otherwise sine of 105, right? 105, because if we need to find sine of 75, what is sine of 75? In different way I can find this actually, but I'm just going to use again different method that we have already used in our previous videos. Let me just add one more slide here and do it here. Okay, so now sine of 75, we have to evaluate sine of 75. Actually, this sine of 75, actually we know that the sine of 75 degrees is equal to cosine of 15 degrees. Okay. Actually, we don't have to change this. I'm just reminding you about this. So suppose that we are given a triangle. Okay. You just draw this like this and like this. All right. So suppose that this angle is 75 degrees. So at the time, this angle should be 50 degrees. So this angle is 90 degrees. All right. This 75 degrees, let me just divide this into two parts. So here we have, I'm going to divide this like this. Actually, it will not be drawn to scale, unfortunately. I think maybe I should draw this a bit. Sorry. Let me just draw this here. Okay. So this is 90 degrees, and this angle is 15 degrees. This 75, right? This 75, I'm just going to draw another line here. Okay. And so this angle is 60 degrees, and this angle is 15 degrees. So which means that this side is equal to this side. If it is 60, this angle should be equal to 30 degrees. Let's write this 60 nicely. Okay. Let's continue. Now from here, suppose that this side is equal to 1. Okay, 30 degrees. So this side then should be equal to 2. And how about the side which is faced by the angle 60 degrees? It should be square root of 3. Since it is 15, 15, also the length of this side should be equal to 2. Okay. Now from here, I can find this c, right, the longest side. So and then after that, we can find what is the sine of 75. So what is c squared? C squared is equal to 1 squared plus 2 plus square root of 3 squared, which is equal to 1 plus, here we have 4 plus 3, that's equal to 7 plus 4 times square root of 3, which is equal to 8. So now from here, what is c? C is square root of 8 plus 4 square root of 3. And 8 is a square number, so we can just take this out of the root. So that's equal to 4 square root of 2 plus square root of 3. Okay, so now from here, we can find sine of 75. Sine of 75 degrees, that's equal to opposite side in the right angle triangle. That's 2 plus square root of 3 over hypotenuse. That's equal to 2 times 2 plus square root of 3. Okay, which is equal to, actually this 2 plus square root of 3, I can write it as square root of 2 plus square root of 3 squared, so they cancel each other. So that's equal to 1 over 2 times 2 plus square root of 3. Okay, so that is the value of, what is it, sine of 75. That's equal to square root of 2 plus square root of 3 over 2. Now let's get back to our question. Now from here, I will continue. So this, what is c then? This c is equal to 16 times square root of 2 times the sine of 75 is equal to square root of 2 plus square root of 3 and over, and here we have 2. Okay, so now dot, dot, dot. So for this answer, the c, what is AB? AB and is equal to 2 cancels each other. So that's equal to 8 times inside. Here we have 2 times 3 is 4. Here we have 4 plus 2 square root of 3. Actually, this 2 plus square root of 3, it is just equal to 8 times, here we have, that's equal to square root of 3 plus 1 squared. Because if you expand this, 3 plus 1, that's equal to 4. That's 2 times square root of 3 times 1. So now, which means that here this AB is equal to 8 times square root of 3 plus 1. That is the length of AB. In the last question, it says that hence or otherwise find sine of, what is it, 105. And by using the trigonometric identity, we know that sine of 185 is equal to 180, sorry. So that's equal to sine of 180, because sine of alpha is equal to sine of 180 minus alpha. So here we have 105. And which is equal to sine of 75 degrees. Now, sine of 75 degrees we have just found here. That's equal to square root of 2 plus square root of 3 over 2. And that is the value of sine of 105 or sine of 75. Okay, question 4. In triangle ABC, A equals B equals 1. Angle C is equal to 30 degrees. Find C. Okay, so A and B, they are equal to 1. So I can just solution. Let me draw this here. I don't know what kind of triangle is it. Let me draw this like this. It's an actual isosceles triangle. So A and B, that means that this vertex is A and this vertex is B. So this side is, and this one is C. So and the sides, actually this AC, that's equal to B, that's equal to 1. And also B, that is BC, or A, that's also equal to 1. And also it says that the angle C, that's equal to 30 degrees, 30 degrees. What is the question? We have to find C. So since it is so, we can just use the cosine theorem or rule to find the value of C. By using cosine, so here we have C squared is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times cosine of 30 degrees, which is equal to 1 squared plus 1 squared, that's equal to 2 minus 2 times, what is cosine of 30? Cosine of 30 is equal to 1 over, sorry, it is cosine of 30, that's equal to square root of 3 over 2. So 2 cancels each other, so that's equal to 2 minus square root of 3. And since we have to find C from here, dot, 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 the value of C will be equal to square root of 2 minus square root of 3. That is a value of, what is it? Let's see. Actually, the figure is not drawn to scale. 30 degrees should be a bit narrower than this, than it looks in the picture, in the diagram. Anyway, after all, we're just actually evaluating this, and that's it. Another question, in the diagram, AE, the ratio of AE to EC, AE to EC, and is equal to CD to DB is equal to BF to FA, that's equal to 1 to 2. So that means that first AE to EC, if AE is, let's say, this X, EC should be 2X. And DC, right, CD, if it is Y, and BD should be equal to 2Y. And BF, if it is like, let's say it is T, and FA should be equal to 2T. What is the question? We have to find the ratio of DCI, right, DCI to the area of ABC. Okay. Just thinking how to do that. So let me just add some lines. Here, annotation. What color should I choose? Let me choose maybe green. Okay. So here, let me just connect B with I. So here we have B, and this one is our I. Okay. And after that, let me connect A with H so that we'll have triangle, because these regions are not triangles. I'm just trying to have all regions triangular shape. And after that, let me also join C with G. Here we have G, and just connect with C. Okay. So now it looks something beautiful. All right. So first, what do we start here? So we need to find the area of the ratio of DCI to the area of triangle ABC. That means that I'm just trying to express everything in terms of a single variable. Okay. So now, suppose that, let me use blue here. The area of CDI, let's say, is equal to S. Okay, so at the time the area of BDI, because Y and 2Y, it will be 2S. All right, so now another thing is, what is it? If this area is, let's say it is B, okay, and this area should be 2B. And if this one is, let's say this C, so this small triangle, it should be 2C. All right. So now, all right, we have S to S, B to B, C to S. Right. All right. Solution here. Okay, now B and X. So now from this triangle, if you look at this, for example, here, the ratio of FH to HI is the same as the ratio of this area BFH to the area of HBI. And it's the same as the ratio of triangle, AFH to AHI. What does it mean? It means that if I just denote this area by X, okay, and the whole area, actually this area should be equal to 2X. Why? Because the ratio is B to B, right? And also this one is FH to HI is equal to 2B to X. So that's equal to B to X. Okay, so now from here, we can see that actually B to X, that's equal to, what is it? B to X. All right. Okay, B to X as okay. So not S, how about not to confuse? Let me just write here. So that is A, and this one is 2A, right? So from here, so from here, actually this X to X, right? So the ratio of AC to CD is the same as the area of 2B and plus 2X to B plus X plus 2A to this area. And how about this area CIG? Actually, it should be equal to 6A minus 3C, because the whole area, it is 6A. So this area should be equal to 6A minus 3C. Okay, because the area of AB DC, that's equal to 6A. Now, if it is 6A, this should be, okay now, I think it is 6A, that's all. Because the area of ABD, the area of triangle ABD to the area of triangle ADC, that is equal to, what is it? 2y to 2, 2y to y. And which means that from here, that's equal to 2, right? So that means that since the area of ADC, that's equal to 7A, because 6A and 3C, right, that's equal to 7A. Now from here, the area of triangle ABD will be equal to 2 times 7A, that's equal to 14A. No, actually this ABD, 14A. Okay, so now from here then, dot, the area of triangle ABC is equal to the area of triangle ABD plus the area of triangle ADC, which is equal to, what is it? That is 14A plus 7A, that's equal to 21A. So that is the first part. Now we can just find the ratio. So then the ratio of triangle DCI over the area of triangle ABC. The area of DCI, that's equal to A. And the area of triangle ABC, that's equal to 21A. So that's equal to 1 over 21. Or simply, and just leave it as 1 to 21. The ratio of triangle DCI to the area of triangle ABC is 1 to 21. Another question, question 2. Solution. In triangle ABC, angle B is 90 degrees. AB is equal to BC. And D is a midpoint of BC. And connect AD, find cosine of DAC. Okay, so that is, so we are given kind of right angle triangle. And this one is 90 degrees. Okay, let me just label this. Angle B, it is 90 degrees. And D is a midpoint of BC. And let's say this one is C and this one is A. And the question AB is equal to BC. Okay, this AB is equal to BC. And D is a midpoint of BC. And that's a midpoint of BC. And after that, we are just, it says connect AD. Okay, so this one is D, and we connect AD. Okay, this one is AD. The question is find cosine of DAC. So let's say this angle is, okay, this alpha. So the question is, what is cosine of alpha? All right. So now from here, okay, it's not given anything. That's why suppose that actually these are midpoint, all right, they are equal. And also BC is equal to AD. Suppose that BD, that's equal to 1 unit. And also D should be, then it is 1 unit. And how about AB? It should be 2 units, right? Now from here, I can find, what is it? AD. What is AD squared? AD squared is equal to 2 squared plus 1 squared. That's equal to 5. So dot, 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 from here, AD is equal to square root of 5. And that's the first part. How about AC? And AC squared, again using Pythagoras theorem, that's equal to 2 squared plus 2 squared. That's equal to 8. So the length of AC dot dot dot, that's equal to square root of 8. That's equal to 2 times square root of 10. So now I can just write these new values there, and me just using this not red, let me use purple. So this side is, it is square root of 5, and AC is equal to 2 square root of 2, or simply square root of 8. Okay, so we have to find cosine of alpha, and using for in triangle ADC, number 3, in triangle ADC, we can use cosine rule. So what is 1 squared is equal to square root of 5 squared plus 2 times square root of 2 squared minus 2 times square root of 5 times 2 square root of 2 times cosine of alpha. Now, if you solve this for cosine of alpha, okay, here we have, let me just write here, 1 is equal to 5 plus 8 minus 2 times 2 is 4. So here we have 4 times square root of 10 cosine of alpha. Now from here, then cosine of alpha is equal to 5 plus 8, 13. 13 minus 1, it is 12. Right? Over, just divide this by 4 times square root of 10. So 4 cancels each other. It is 3 over square root of 10. Or if you want to rationalize its denominator, multiply numerator and denominator by square root of 10. So that's equal to 3 over 10 times square root of 10. Okay, that is cosine of alpha. So we have to find cosine of BAC. So that's equal to 3 times square root of 10 over 10, or simply 3 over square root of 10. All right. Another question, question 3. It says in triangle ABC, M is the midpoint of BC. M is the midpoint of BC. AM is equal to BM, and BC is equal to 10. The perimeter of triangle ABC is 24 units. Find the area of triangle ABC. Okay, now first let's just draw the picture to visualize this. And okay, ABC, M is the midpoint of BC. So let's say this triangle is maybe something like this. Okay, so let me just draw this and this. Okay, and suppose this vertex is B, and this one is A, and this one is C. Vertex B, vertex A, vertex C. Okay, M is a midpoint of BC. So that is a midpoint of BC. So let me just connect this. So this equals this. And it says AM, so this one is M. AM is equal to BM. Also, they are equal. And BC is equal to 10, which means that this equals 5 units. BM is equal to 5 units, and also this one equals 5 units. Okay. So what else is given? The perimeter of ABC is 24. Solution. And the AC, that's equal to B, and AB, that's equal to C. The perimeter is, what is the perimeter? It is B plus C plus the length of B, so that's equal to 10. That's equal to 24. Now from here, we can see the relation between B and C. So B plus C is equal to 14 units. Okay. What is the question? We have to find the area of triangle ABC. So immediately, suppose that this angle B, let's say it is beta. Okay. Now from here, triangle BMA, it is an isosceles triangle. If you just draw a height, okay, to this side, actually this side should be equal to this side, which is equal to C over 2. Now from here, what is cosine? That is the first step. Okay, the second step is what is cosine of beta? That's equal to adjacent side. That's equal to C over 2 over hypotenuse. That's equal to 5. Now from here, that's equal to just C over 10. That is the value of cosine of beta. On the other hand, in triangle ABC, right, if you use cosine theorem in triangle ABC, what is B squared? B squared is equal to BC squared, that's equal to 10 squared, plus AB squared, that's equal to C squared, minus 2 times 10 times C times cosine of beta. Okay. So now from this relationship, we can just find x plus b in terms of c. That's equal to 14 minus c. So now if we just substitute here, we'll get an equation in terms of c, right? What is b? B is 14 minus c squared. And here 10 squared, that's equal to 100 plus c squared minus, here we have 2 times 10 times c times, what is cosine of b? That's equal to c over 10. So this 10 cancel each other, that's equal to just minus 2c squared. Now if you expand the left hand side, 14 squared, 196. Let me just keep it here. Okay. Minus 2 times 14 times c, that is 28c plus c squared. On the right hand side, we have 100 minus c squared minus 2c squared, that's equal to c squared. So if you just take everything to the left hand side, here we have 2c squared minus 28c, 196 minus 100, that's equal to 96. That's equal to 0. Now from here, what is c? I can simplify further because all numbers are divisible by 2. C squared minus 14c plus 48, that's equal to 0. This quadratic equation can be solved by factorization because 6 times 8, right? That's equal to 48. 6 plus 8, that's equal to 14. So if you factorize this, it is 6 minus 8 and 6, 6, c minus 6 times c minus 8, that's equal to 0. Now from here, c equals 6 or c is equal to 8. If c is equal to 6, b should be equal to 8. If c is equal to 8, then b should be equal to 6. Actually, in both cases, it just gives us the same, what is it, triangle. So I can just pick one of them as the answer. And suppose that c, okay, c is equal to 8. Then b is equal to 6. So we have to find the area of this triangle, right? Now from here, I can find, what is it, cosine of b, beta. Now what is cosine of beta? Cosine of beta is equal to c over 10. What is c over 10? That's equal to 8 over 10, which is equal to 4 over 5. And in a right angle triangle, okay, let me just draw this. All right. So if this one is beta, this should be 4, this should be 5. And the third side should be equal to 3. So from here, then what is sine of beta? Sine of beta is equal to 3 over 5. Okay. So then the area of triangle ABC, triangle ABC is equal to 1 over 2 times AB, that is C. C is equal to 8 times BC, that's equal to 10 times sine of beta. Sine of beta is equal to 3 over 5, which is equal to, it is 4 times 10, 40, 40 over 5, it is 8, 8 times 3, that's equal to 24 units squared. So the area of this triangle is 24 units squared. Okay, question 4. The side length of square ABCD is 6. And the 2AE times is equal to E times D. So AC intersects BC and BD at F and G respectively. Find the area of triangle BGF. Okay. So since it is a square, just right here the solution. Okay, and 2 times AE is equal to ED. And since the side length of this square is 6, let's say it is 6, it is 6, it is 6. So 2 times AE is equal to ED, right? So AE should be equal to, what is it? It should be 2. Then 2 times 2, that's equal to, this ED must be equal to 4. Okay. So, and since actually BD and AC, they are, what is it, diagonals of this square. So that means that they intersect each other at G, and the area of BGC is equal to the area of CGD is equal to the area of DGA and area of AGB. Okay, since the area of square, right? So since the area of ABCD, that's equal to 6 squared, that's equal to 36. And 1/4 of this area will be 9. So this BCG, it will be equal to 9. And also this area, for area, let me just use different color. Let's use blue. So this area is equal to 9. And also this area is equal to 9, right? And how about the remaining areas? That's equal to, again, it is 18, 18. That's equal to 18. And we have to find the area of BGF. Okay, that BGF, suppose that that area is S. Okay, so if it is S, and let me just actually connect point E with G. If you just connect this E and G, here we have E, okay, E and G. Okay, this F is quite big. Okay, so that is S, right? So we know that the area of ABG also is equal to 9. So this remaining part, this ABF, it should be equal to 9 minus S. So this triangle EFG, let's say, is equal to X. The remaining part, it should be equal to, what is it? It should be equal to 3 minus X. How do I know that? Because the area of AEG, that's equal to 3. And EGD, that's equal to 6, because the size, right? AE to ED, that's equal to 2 to 4. And also the ratio of the area should be 2 to 4, that's, which is 1/10. So since the area is 9, so this part AEG, it must be equal to 3. So if this small region is the X, the remaining part should be 3 minus X. Now from here, actually this, let's say 9 minus S, the area over S. So that's equal to AF to, what is it, FG, right? And also, what is AF to AG? That's also equal to the area of AEF. That's equal to 3 minus X over the area of EFG. That's equal to X. Okay, because one side, actually, they have a common side, these two triangles. Now from here, if you just solve this, combining these two equations, on the left-hand side, we have 9 minus S minus 1. On the right-hand side, 3 minus X minus 1. Minus 1, they cancel each other and cross multiply, dot, dot, dot. What is S? S is equal to 3X. That's our first step. So we just found the relationship between S and X, right? So now from here, okay, continue. The second one. And what is the area of okay. Yeah, that's it, I think. Now from here, what is the area of triangle ABE? Triangle ABE, that is equal to 9 minus S plus 3 minus X. That is equal to, right? That's equal to 1 over 2 times 2 times 6, which is equal to 6. Now from here, 9 plus 3, that's equal to 12, minus S minus, what is X? X equals S over 3. That's equal to 6. Or if you just solve this for S and take to the right-hand side, S plus S over 3, that's equal to 12 minus 6. Or multiply both sides by 3. Here we have 3S plus S is equal to 12 times minus 6 is 6. Multiplied by 3, it is 18. Now from here, 3S dot, 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 what is S? S will be equal to 6 units squared. No? It's not. It's 12, 36. Okay. So this 4S, right? Okay, 9 minus S plus, okay, 3 minus X. That's equal to 12 minus S minus X. X equals S over 3. On the right-hand side, 1 over 2 times 6. That's equal to 6. So that is 4S is equal to 18. S is equal to 18 over 4. That's equal to, by 2, 9 over 2. Okay, S is equal to 9 over 2. Okay, I think this is our last question for today. Running out of time. And this question says the side length of square ABCD is 1. 5. Just take this. The side length of square ABCD is 1. AE to AB is equal to BF to BC is equal to CG to CD is equal to DH to DA is equal to 1 over N. Okay, so if the area of the shaded region is 1 over 181, find the value of N. Okay, so here since the side length is equal to 1, okay, okay, so X. All right. If here we have, let's say this one is X, so this should be 1 minus X. So from here, DH, the last one is that is X over DA, that's equal to 1, that's equal to 1 over N. Okay, if it is X, it should be 1 minus X. So 1 minus X over DA. What about if I label like this? Okay, if this one is, let's say this X, this should be 1 minus X. So at the time, here we have, what is it? DH, 1 minus X over DA, that's equal to 1. That's equal to 1 over N. I think it doesn't matter. In each case, N is equal to 1 minus X. Anyway, whatever it is, okay. So since it is the smaller part, I can just label this by X. So this one is X, 1 minus X. And also this is, let's say this X, 1 minus X. So this is X, 1 minus X. This is X, 1 minus X. Okay, but here it says the ratio, even if I just label this like Y, 1 minus Y, and Z, 1 minus Z, when we are just taking the ratio, it will be gone. That's why I'm just taking as the same. Okay, it doesn't change because if it satisfies for every value of X, when they are actually proportional in this way, also it must be, it must give us this the correct result. So the area of the shaded region, that's equal to 181. And also let me just label these areas by some letters. Let's say, so this area is, let's say this A. So also this should be equal to A. And also this should be equal to A. And this should be equal to A. And this part, okay, let's say that, let me label them by B. So this one is, it is B. And this one is B. And this one is B. And also this one is B. Now from here, what I know here is solution AAA 4A. So here we have 4A plus 4B, right? and plus 1 over 181. So that is equal to the area of this square, which is equal to 1. Okay, from here, what is a plus b? A plus b is equal to 1 minus 1 minus 1 over 181 over it is 4, which is equal to, and 181 minus 1 is equal to 180. 180 is divided by 4, it is 45. So that's equal to 45 over 181. That is the sum of these two triangles. Okay, so that is the first one. Let me just write this first step. Now we know the sum of a plus b. The second one is, okay. The second one is, if I just divide this into two parts, okay, from here, okay, it is symmetric. At the time, if you look at this triangle, this will be b over 2. And also this part will be b over 2, because it's a kind of, what is it? I don't know, I don't know. Okay, so now from here, actually, b over a over b over 2, that is a, right, over b over 2 is equal to 1 minus x over x. So from here, what is it? 2a over b is equal to, okay, it is, no, not like this. Sorry. Sorry, if I just divide this, okay. Triangle, not like this. I think I should divide this like this. Okay. Anyway, so the time, okay, suppose this part is b over 2, and also this one is b over 2. Because a kind of, what is it? Isosceles trapezium. Okay. So now from here, because triangle B and C, and whatever this point is divided into two parts, right? So from here, B over 2 over b over 2 plus a. So that's equal to, what is it? This x over 1 minus x. X over 1 minus x. I think I better write like this, upside down. So a plus b over 2 over b over 2. We're just taking the ratio of these two areas. That's equal to 1 minus x over x. So on the left-hand side, if you just simplify this, 2 goes up. Here we have 2 times a over b plus 1. That's equal to 1 over x minus 1. Or you can just find from here, a over b is equal to let's say 1 over x minus 1 or 1 minus x over x, right? So that's equal to 1 minus x over 2x. Okay, that's the value of a over b. And on the other hand, actually, b plus 181, because if you just split this from b to d, okay, let me wait. So from b to d, if I just join this diagonal, at the time, what it will be dbf, it will be the half of these two triangles, right? I mean, this in the middle between these two parallel lines. So number 3. Okay, running out of time. So it will be b plus b, this 2b, half of 2b is b. b plus half of 181, the shaded region, 181 over 2. Over, and that's equal to 2a plus b. That is 2a plus b. On the right hand side, that's equal to, it is again x over 1 minus x. X over 1 minus x. Okay, so what is x over 1 minus x? X over 1 minus x is equal to b over 2a. Now from here, b plus 181 over 2 over 2a plus b. That's equal to x over 1 minus x is equal to b over 2a. Now, if you just solve this for b, you will get what? So we will get that here, actually our b will be, it is, okay, n minus 1, n minus 1, it's gone. So that's equal to, it should be equal to 1. Quickly cancel each other, n minus 1, n minus 1. So that's equal to 1. So b, okay. Anyway, if we just cross multiply, here we have 2ab plus 2 to cancel each other, 181a. On the right hand side, 2ab plus b squared. So this 2ab, they cancel each other. So 181a is equal to b squared. Okay, at least we know what is a. Okay, now that's it. Now from here, we can just find the area of, I mean, this thing. Okay, let me just finish here. Unfortunately, we don't have enough space. So 4 times, instead of a, I can substitute here, 4 times, we have to find n, right? To find n, we need to know b. Okay. So anyway, 4 times a plus b. What is a? A is equal to b squared over 181 plus 4 times b plus 1 over 181, that's equal to 1. Now, if I just multiply both sides by 181, and here we have 4b squared plus 4 times 181, 4 times 181, that's equal to 724b. And here we have multiplied by 181, it is 1. Take to the right hand side, 181. So here we have minus 180. That's equal to 0. Now we have quadratic equation. By solving this, we can get b. If we know b, we can get a. And using the ratio, we can find a. We have actually run out of time. That's why I have to finish here. Thank you very much. Bye-bye.